Thanks everybody for showing up. Hopefully you get a lot out of the next couple of days, and hopefully this is the start of something that's pretty fun for you guys. We have a lot in store for you this weekend. Hopefully you get a lot out of it, and I really say thank you very much for participating in this first session in the game track to hear me talk about the fundamentals of creating an HTML5 game. Now, before I started, I was actually playing a song before I actually started speaking here. Anybody recognize it? No? Okay. Well, it's kind of an obscure song, but it actually will help me sort of set the stage for exactly what we're going to talk about here today. And I think you'll appreciate the story behind it. So basically, my wife is a big fan of the band Bon Jovi. A lot of you probably already know this. I recognize a few people in the crowd, so it's possible that you may have heard me say this a few times. And because my wife loves Bon Jovi so much, I get to know the songs quite well. And in their latest album that they had, there was a song that they called When We Were Beautiful. Now, the song title is actually kind of weird, and I get that. But if you listen to the lyrics about it, it's actually a retrospective about their career, you know, starting off as a high school band that was just, you know, mucking around in their garage, learning to play instruments and actually learning to do the craft of songwriting. But they also talked about the fact that, you know, that naivete that they had actually helped them sort of have a sense of wonder about what music was. Now, let's take a look at that and where they end up today, right? They're big rock stars and stuff like that, but they are able to look back. They're not bigger than themselves in a lot of ways, and they're able to look back at themselves and say, you know what? We started off so small, and for a lot of the things that we've done, yeah, we've changed throughout those years, but we've actually kept that same sense of wonder. Now, the reason why that's important to gaming is because I want you to think back to the day that you first actually had a computer in your home. For me, that was a Commodore 64. Anybody here have a VIC-20? Yeah, over there? Yeah. Joust was a great game, wasn't it? Yeah. But the reason why I bring this up is because the very first time that you unboxed that PC, or computer at the time, I guess you could say, in my case, the Commodore 64, you know, you opened up the box, you set up all the cables, you connected it to a TV, because that's the way it was, or the monitor was a TV, a cathode ray tube thing. And you really thought about getting into the computer and really starting to play around with it, right? And for most people, especially when you were talking about the days of the Commodore 64, the VIC-20, and maybe the Amiga, it was really interesting because that first experience was largely on the gaming side. So when you took a look at some of these games that you started playing, that's when your sense of wonder about computing actually started. Your sense of the love affair that you have today as an IT professional of some sorts, or a developer on the side, or whatever it is that you do, you actually got the ability to have that sense of wonder from that first computer and from those games. But at the same time, now here we are, X number of years later, and there's a lot that we know that we didn't know before, and sometimes that makes us a little bit jaded about, you know, opportunity and everything else like that. But one of the things that you do notice is that you can think back or reminisce back to those first days of actually playing those types of games and thinking back, weren't those the great days? Well, game development will help you bring those back. And really, this is what this is all about. Get your wonder back, get your sense of fulfillment from, you know, doing something that was creative and everything of that nature. So really, that's what this session is going to be about. So enough preamble. Except for the fact that I should introduce myself. My name is Paul LaBerge. I'm a technical evangelist with Microsoft Canada. My role at Microsoft is to help developers such as yourselves really understand our platform. And that is a very broad term, I guess you could say, platform. And the interesting thing about it is that it is broad, sort of the things that I do and my colleagues do as well. So my main focus is on the Windows Phone side of things. So I'm one of the lead evangelists on Windows Phone here in Canada for application development and game development. I also help out with Windows 8 or Windows Store apps as well. And as well as that, I deal with the Windows Azure side of things, and I support that side of the business with my colleagues as well. So if you have any questions, feel free to give me a shout. My Twitter handle's there. And also you can follow us at wootstudio.ca, where we're going to be talking a lot about, app development and game development and how you can connect them via Azure services and cloud and everything else like that. So with that done, let's actually get to the next slide, which is basically the social side. So if you're interested in actually providing some feedback, or you have something to say about this session or the event in general, our Facebook URL is right there, as well as you can see the Win8PI hashtag. We suggest and highly recommend that if you're going to tweet about this event, use Win8PI, and Purely Imagine is the Twitter handle that this event will actually have. So feel free to interact with us. That's what we're here for, and we'd love to hear from you. Finally, if you want to tweet specifically about this session, you can do so using the hashtag GMG1 for Gaming1. And of course, obviously, use that Win8PI hashtag as well. That will let us understand exactly what session you're talking about, and so that we can have a better conversation with you around what that session was all about. So with that done, let's actually get into it. And when you talk about games, games are a very detailed subject. And when you first get into game development, you may not actually know what you're getting into, because there's a lot to it. If you think about game development in general, there's a reason why some of the best developers in the world literally are working at some of these game studios and these game companies. Because I will not sugarcoat it, game development can be hard, especially if you're doing very involved games like the Halos of the world, or the Call of Duty, whatever those types of things might be. Those are extremely, extremely busy games and require a lot of manpower to actually make them actually come to life. That said, there's another sort of side of gaming, the casual gaming or the social gaming that we say, that is also could be fairly difficult to do, but it's actually extremely popular. And this is a great way for everybody that wants to learn how to build games. It's a great way to actually do that. And that's basically the stance that we're going to take with this track going forward, is talking about the social gaming side of things. So in order to start that, I'm going to do a bit of an HTML primer, because we're going to talk mainly about building games using HTML, JavaScript, and cascading style sheets. And then we're going to talk a little bit about game structure. So what is a game when you talk about a program or an application? How do you sort of set it up? What is the methods, and what is the pattern that you actually use to actually create a game? And then I'm going to do a very quick introduction to something called Yeti Bowl, which you'll hear a little bit more of in future sessions in this track. So hopefully we can get through that. And if you have any questions, feel free to ask throughout the presentation. So let's talk about the HTML primer. The first thing that you need to know about HTML, and when I say HTML, we're going to talk about what's called the umbrella technologies of HTML5. HTML5 is actually something that a lot of people have heard before, but it's not something that they necessarily understand. And this is kind of interesting, because when you talk about HTML5, HTML5 means a lot of things to a lot of different people. And if you take a look at what HTML5 really is, when most people talk about it, it's bigger than what HTML5 actually is, right? So HTML5, when most people talk about it, they're talking about the set of standards that is the World Wide Web Consortium is going to be generating to define the new web experience. So everything from a rich media experience to a rich interactive experience, and all other things that come with it that can create these web experiences that are non-traditional in look and feel and interactivity. So gone will be the days where all you can do on a web page is create a radio button or a checkbox or a list box with a button, forms-based development and things like that, which is still relevant and very, very much part of the whole web side of things today. But the whole idea is that as a web developer, it's very difficult to create these cross-browser or cross-platform experiences because of the fact that each browser interprets certain standards or interprets certain things differently. And some browsers support certain features while others don't. So as a web developer, you have to sort of test for all of that. And it sort of breaks the promise of the web being the end-all be-all for any sort of browser, regardless of whether you're using Chrome, Internet Explorer, Firefox, Opera, Safari, whatever. So around that, the World Wide Web Consortium decided to create the umbrella set of standards over HTML5. Now, HTML5 is, from the umbrella standards, are basically around this big, if like each standard itself is around this big. Very, very big. HTML5 proper, the things that talk about the markup side of things, is really around this much of the HTML5 standard. Then you have JavaScript and CSS and then some geolocation stuff and everything else like that. So it's actually quite wide and diverse as far as what these standards are. And the interesting thing about this is that these standards are still a bit of a moving target. Around a third, I would say, at this point, and that's not a scientific number, but around a third anyways, of these standards have actually been ratified to date. With the rest of the standards, the expectation is that these standards will actually not be completely ratified until around 2014, 2015. So we're talking about a bit of a moving target. So we're not quite at the nirvana, I guess you could say, of web browsing and great experiences that are standards-based, but we're very much getting there. So keep that in mind when you're actually building games and HTML sites that use HTML5. There's still going to be a bit of a difference between browser to browser as far as how each of those browsers sort of interpret standards today, because some of these standards are still in working state, not in final state. So getting back to the slide, what we have here is what's called the canvas element. And the canvas element was something that was actually brought on to the markup side of the standards around HTML5. This is fairly new. And the canvas itself is exactly what you might think it is if you think about it in artistic terms. A canvas is a blank something that allows you to draw on or create something on, or generally do something that is creative and interactive and everything else of that nature. And as you can see here, the syntax is actually very, very easy to understand. Canvas, you give it an ID, and then you close it with another tag. Now there could be some stuff inside that, and we'll get and show you a few examples of that, but that's basically what we're looking at. So here's how you actually draw something to the canvas. And I'm not going to go too detailed into the actual slide itself, because I'm actually going to show you a few demos of this first. But basically what you have to do is you have to create a variable that holds an image type, okay? And then once you have that image, you say what the source is, as you can see right there, in this case it's a PNG, and then you basically say image on load, which is basically when you load the page, you actually do something to the image, and then you can set up the code to actually draw it to the canvas. Fairly simple. Now the other thing that you have to keep in mind is this. So these two things that you see right here, canvas element, which is basically going to be a variable that holds the actual canvas within JavaScript. So the hypertext that you actually showed, that I showed a couple slides ago. And then basically you're going to get it from the game canvas, from what you saw there. And then what you do also is you say that the canvas element get context is 2D. So the reason why we say this is that there's two options here. You can do 2D or 3D, which you can probably imagine means two-dimensional or three-dimensional. Now this is really important when you're talking about gaming, because if you know anything about gaming, you'll notice that there's a lot of talk about these two sort of concepts. Two-dimensional gaming and three-dimensional gaming are kind of what you would think, right? So two-dimensional gaming means things are flat. So a great example of that is Angry Birds. There's no sort of 3D elements that sort of pop out at you. It's really just a flat canvas, and the bird just goes sideways and whatever else like that, which is fine. But in addition, there's also 3D. And 3D is where it gets really complicated, to be honest. So basically what we end up having is, games that are 3D include things like Halo and the Call of Duty, the types of things that I showed you before. And they're very involved because you have things to deal with such as pixel shaders and sprites that you may have to work with on a one-by-one basis. And you have other things such as like light sources. So where does a light source come from? And as your figure moves, or as your game board moves, or whatever you want to call it, that light source will change things. So there's obviously a lot of calculation going on. So we're going to focus solely on 2D in this session, and I believe pretty much most of the other sessions that you see out there. But you can do three-dimensional gaming, but it is much more involved, and it's something beyond the scope of what we're going to talk here today. So every single example that you see here going forward will be a 2D example. Any questions? All right. So here is where the rubber meets the road as far as actually drawing an asset to the canvas. So using the examples in the previous slides about, getting the context, actually defining the hypertext for the canvas as well, just imagine this. This draw image function is something that's provided to you to actually get the image onto the canvas itself. So the image that you can see there in the parameters, the first parameter, was something that we put into a variable prior in the, I guess it was a couple slides ago. So that's a variable holding that. So we've actually got that image there. And then we're saying that the source position is 0, 0, which basically is your top left-hand corner. And then what you're saying is the source size, so you're going to actually define the size of the image that you want, so whether you want to stretch it or whatever it is that you want to do. And then say the destination position, right? So basically what you're saying at this point is you're saying that you actually want to have the have the start of the image, the top left-hand side of the image, to be at the 50 pixel from the left and 100 pixels down from the top of the canvas. And then obviously destination size is there, which you can see there as well. So pretty simple. It's actually quite easy, as you saw, to actually put an image onto the canvas. So that was just a bit of a primer on Canvas around how you can actually just put an image. But let's go through a bunch of examples of what Canvas can do and how it can be useful to you. Because I think one of the things that you'll find is that even though most of the examples I'm going to show you right now are not specific to a game, even though the last demo that I'm going to show you right now is a game, you need to understand all these things to actually make it work. So that's basically what we'll go to next. So I'm just going to bring up Visual Studio. Now, just going to take a quick drink here. Everybody here seen Visual Studio before? Yeah? Some of you not? Okay, so let me do a quick overview of what Visual Studio is quickly. So Visual Studio is the premier development environment that Microsoft provides to developers to build solutions, whether that's enterprise software, Windows Store apps, Windows Phone apps, Azure services, whatever it is that you're trying to do. It's been around forever in one form or another. It's been together as a full-fledged studio product since around 2000, 2001, basically when .NET first came out, where we actually brought a whole bunch of complementary products like Visual C++ and Visual Basic and a few other things that we actually brought into the fold together. We've revved it several times, and what you see here is the latest and greatest version of Visual Studio. And what I'm running is the Ultimate SKU, and this is the most expensive SKU, so you may not necessarily need all the features of the Ultimate SKU, but if you're doing anything to do with HTML proper rather than actually building a Windows Store game or Windows Store application or a Windows Phone app for that matter, you do need the Pro version at the very least to actually do this, because the Express SKUs, as they're called, which are the free ones, allow you to build a game or an application in Windows or in Windows Phone or anything else like that. But if you want to do full-fledged web development, you do need the Pro SKU, but it comes with a lot of value with it, and I'd be happy to talk with you about that after the fact if you're interested. So with that said, I'm really only using Visual Studio here today because we've already got these applications or these web pages already built up just to sort of launch things. So the first thing I'm going to do is show you this right here. This is basically a basic example of Canvas. Now I'm actually going to bring this down. I don't need any of that. I'm going to make this slightly smaller. Okay. Can everybody see this in the back? All right, so this is an HTML5 document. The way you can tell is that we only have the doc type HTML. There's a whole lot of goodness that we've actually done as part of HTML5 to make it less verbose in some ways, so you don't have to worry about stuff. So here we are. I'm going to deal with the script later because I think it's important first to show you. So here is a canvas right here. Okay, and that's pretty boring and simple. Now, that's kind of important, because what you're seeing here is that this is something that is showing that the canvas itself is not where the magic happens. It's actually what you do with the canvas in other components of your actual website. So as you can see here, we have canvas and then a closed canvas right here. And inside we say canvas is not supported, which seems sort of odd, but if you've done any sort of web development before, this actually kind of makes sense. So basically what this means is that any older browser, such as IE6. Anybody remember IE6? Yeah, okay. Basically, any sort of browser that doesn't understand the canvas tag, which most older browsers will not understand it, will ignore the canvas tag and actually go on to the first piece of text associated with it or a tag that it does know. So in other words, if you're running this in IE6, IE7, or an older version of Chrome or Firefox, for example, it'll ignore the canvas tag and then it'll just write out canvas not supported. Now you can have whatever message you want there, but basically this is a way to sort of explain to your users that they're using an older browser and they cannot make use of this canvas enabled game or whatever it is that you decide to build. Now let's take a look at what I'm doing inside the canvas. So I got a script. Now this could have been as easily a script outside of the actual page, but I have it inline. And basically what I'm doing is I'm adding what's called an event listener. And an event listener is something that is used within object-oriented programming to say that when something happens, fire something off, right? So in this case, we're saying that when the window is loaded, which you can see right here, fire off this function, which we're going to define here. It's an anonymous function in HTML. So the first thing that we're doing is we're actually going to get the canvas into JavaScript memory by doing document.querySelector canvas. And then if it can't find the canvas or if you can't get the context, then do nothing. Otherwise, set the context, say canvas.getContext equals 2D. Remember that 2D versus 3D thing that we were talking about before. And if you can't get the context, again, return, so don't do anything. But if you can, then the first thing we're going to do is create something called a gradient variable from the context and create a linear gradient. And there's just a few sort of parameters here, which basically are the starts and stops and everything else like that for the size. And then we're adding color stops. So in this case, we're saying for the gradient, add white, which is pound FFF in hex, to the start of the actual thing that we've made, this create linear gradient. And then a color stop of blue, so you can do hashtags or hash codes, I guess you could call them in HTML, or actually use the codes that they actually have associated with HTML as well, such as cornflower blue or green or whatever it is that you want, and that'll be at the second color stop. And then we're going to say fill style equals gradient, so for the context, and then at that point say fill the rectangle. So we're actually creating a rectangle. And if I actually run this, just wait for it to show up. There you go. So nothing too wild here, but this is really important because if anybody, I'm going to right click on this first to show you that this is not an image, right? So you can see right here, I'm right clicking, not an image. So this is actually the canvas. Now the cool thing about this is that if you've ever done any sort of web work before, creating gradient type style shapes or anything else like that required you to do all sorts of unnatural things, either in the CSS or within JavaScript or even just generating images on the fly, which can get a little nasty if you've done it before. Yeah, I see. You've done that before. Yeah. Okay, so anyways, this was really easy to do, as you can see, right? So that's kind of cool. Now, that's not a whole lot going on there. And what we're going to do here is we're going to go to the next one. Now this one, we're going to actually do something a little bit different. Now to make this one a little bit more easy to understand, I'm going to actually run it first so you can actually see it. Again, just wait for it to show up. Okay, so got this button and we got this thing here, which doesn't look like much. And trust me, it's not broken. I'm going to show it to you in a second here. So I'm going to move my mouse over here. Oh, look at that. Got all sorts of whatever going on. So I'm making a doodle just like my son's Etch-a-Sketch. And then I'm going to save it, and there it is right there. Now, if I right-click on this, you see this isn't an image here. This is just whatever, and that's where your canvas is. But if I right-click on here, aha, save picture as. So it's actually a PNG file, and I've actually built this on the fly as well. So let's take a look at the code. As before, let's take a look at the hypertext first before we do anything else. So we have a canvas. And we made the canvas a little bit more detailed this time, so we've defined a width and a height, right? Nothing too wild, but still it's a little bit more detailed than the previous example. And underneath we have a button, which you saw, which was your save button. And then right here, right to the other side, is your image. right? So there's nothing going on here. It's just literally setting up an image tag there as well, which is why it looked broken when you actually saw it on the first start of the page. So let's take a look at what's actually happening here. So again, the magic happens in the JavaScript, and we have an inline JavaScript set of functions here. So I'm going to go to save in a little bit, but what I'm going to do first is I'm actually going to go to the load event listener, which we're creating an anonymous function. Again, the same type of thing that we did before, getting the canvas into JavaScript memory, defining the context, and then basically creating a variable called started, which sort of defines whether or not you've actually started making a picture or something like that. So that's just a Boolean that we're going to provide. Now we're also adding an event listener to the canvas, mouse move, right? And it's going to be another anonymous function that's going to take a single sort of parameter here. And basically what this is doing is it's saying, okay, for every single time that the mouse moves over a certain time period, make a point, right? So you create the point, and here's basically what you're doing. So you've created a path, move from X to a new position, and then using that new vector or position if you want, create a line for it and actually create a stroke. So literally that's how you're actually creating the image. Now that's good, but that's not the end of it, right? Remember how we saved it to an actual image. So what we're going to do next is I'm going to show you that save button, and this is where it gets really easy. So whatever we did on the canvas, again, we're getting a variable called canvas that we're actually going to get the canvas into memory again. And then every single time that save button is hit, this is going to be loaded on, or this is the event that's going to fire. Basically get element by ID, the image, so get into, basically what we're defining here is we're saying that the image that we're going to be loading to that image tag is going to be the canvas to data URL. And that's it. That's all. That's all we have to do. And then it's actually creating the image, which you saw, which was a PNG, which is the default. So again, you can create these really interactive things fairly easily using that alone. Now let's take a look at the next one, image. Sort of talked about this in the slides a little bit, but I want to show you a little bit more here. So again, I'm going to just start it in Internet Explorer here. Wait for it to come up. All right, nothing too wild. So we created an image, big deal, right? Well, let's take a look at this. I'm going to right click on this. I can't actually save it because it's not an image, because I've actually loaded it into the canvas. And the way you can think of it is, I'm going to use an Apple idea here, okay, just because most people here probably have an iPhone or an iPad or something like that. When the iPad mini came out, you know, and you first saw it at the store and things like that, you may have seen one in the store prior to actually the store opening the day of, and you're looking at it through the glass window going, boy, would I love to play with it, right? Well, you can't because it's behind the glass. Well, this is the same sort of idea. The canvas in this case is the glass that is keeping you from actually touching the image, in this case right-clicking and saying save as, which is kind of cool because if you want to do something that makes it a little tougher for a user, say for example, to save that image, you know, copyrighted image or whatever. Yeah, you've had that problem too. Yeah. yeah, I hear you. You're a photographer, you said? Yeah, I remember you saying that before. Yeah. Okay, so basically what we had here was we have a situation where you can't get at the image, right? So, but it is actually an image that we're using. Now I'm going to show you the actual code. Here we go. All right, so again, canvas. So in this case, canvas, height equals 284. So you see here, you can define a height but not a width if you don't want to, and that's fine. Now let's actually take a look at what's happening. So again, adding the event listener for loading the page, getting, putting a variable of type image or creating a new image into this fish variable, and then adding an event listener for this variable on the load of the page. Say get the context of the canvas, right, 2D, and then we're going to draw the image of a fish to these coordinates, and saying here, defining that the fish source is images.fish. So this is something that exists locally on my IIS server that I'm actually using, and that's it. So it's actually using fish.png to actually load the image, but you don't actually see this image anywhere, okay? As far as like right-clicking it, as I should say, on the web page, but it is there. So that's kind of cool. Next one. transforms. So again, canvas, nothing too wild here, just height and width is what we have. And then what we're going to do here is do a little bit of algebra. So I'm not going to go through the code very, very detailed because a lot of it is similar. But basically what we're doing is we're doing some rotation. So using some algebra to do transformations, and every single time there's a transform, actually create a fill style for the new transform and then fill the rectangle with that. And if I take a look at this, basically what I'm doing is, wait for it. There you go. Nothing too wild there. But you can see this is doing something dynamically. It's not an image on its own. In fact, the rectangle that I created is not an image at all. It's just something I created with JavaScript onto the canvas and then I rotated it. Which could be very, very useful if you're doing things like gaming, right? All right, next one. Video. Video is interesting because it's another thing that allows you to do cool things with video on HTML5 without the need of a plugin such as Flash or Silverlight or anything else like that. So let's take a look here at the video tag, which is a new HTML5 HTML5 tag. And we're basically, as you can see here, there's no object definition, which is typically what you see with a Flash video or a Silverlight video because there's no ActiveX or anything else like that. And basically all we'd have to do is say, give it an ID in this case because we're going to use it in JavaScript, and then give it a source, right? Very simple. And then we're going to say autoplay equals true, which basically means that, you know, when you load the actual page, it's going to start playing regardless of whether or not the user wants it to. And that's it. And then we have a break. So right underneath the video, we've got a canvas, which is empty. Now let's take a look and see what happens here. Okay, so we got the video playing up top. We got the canvas down here. Just let this play a little bit longer. There's a part of this that I think is really funny. Here we go. Wait for it. Wait for it. Wait for it. There you go. I love that part. Okay, so let's find out exactly what we did here. Kind of cool, right? You had this idea where you had a video on top and it was sort of superimposing it on the background. It kind of looked like it was reflecting, right? So let's show you how this actually works. So again, just doing the usual thing around adding an event listener on load, loading into memory the video, the canvas, and the context, and basically setting the video width and height and all that kind of stuff and do a translation. So basically what we're doing here is we're saying the canvas, right? We have canvas.height equals the same height as the video, or as the video.height equals 200. And then from the context, we're saying translate the actual context here to 200 and then flip the video using an inverted matrix. Pretty simple. Then in addition to that, after that, we're going to use our friendly gradient that we showed you before. So just creating a rectangle gradient, saying adding a color stop from, you know, completely black or no, basically whatever it is there, or I should say completely white, and then adding a color stop here, and then basically filling the gradient. So basically what this is doing is it's actually creating a fully opaque, or a fully opaque to fully transparent near the end. And then what we do at that point is we set interval, right? So basically what this is saying that every single time that there's a new frame within the video itself, we're going to grab that frame, make a picture out of it to, well, not really, yeah, actually make a picture out of it, I should say. Have that picture inverted and superimposed on the canvas. So it actually makes it look like there's two videos running at once, when in fact you're actually just taking frame by frame pictures and putting that onto the actual canvas, which gives that nice effect, which you saw before. So there's all sorts of interesting things that you can do there, which actually you can use within your HTML5 games as well. Okay. Any questions? No? Okay. All right. Now the game. Okay. So this is a game, and I'm not going to go into great detail in the code. You can get it after the fact if you want it. But I will show it to you first because I think that'll give you the context of what we're going to be talking about, and then I'll go very quickly through the game code because it is fairly involved compared to the other examples that we had. So just wait for it. Here it is. Blah, blah, blah. This is my game song. It's an awesome game. Aliens, 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 la, 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 la. That's it. Okay, see? Blah, blah, blah. This is my game song. It's an awesome game. Okay, enough of that. I don't need to hear myself anymore. So as you can see, it's an alien game, and it's the worst example of us overreacting as Earthlings to aliens, because as you saw, the aliens don't do anything. They just fly around and then we shoot them down, which is quite sad, unfortunately, but that's the way this game actually works. But let's take a look at this. So you can tell already that, you know, when I said building a game can be a little bit of a different task compared to typical things, this game is not very long, but it is much longer than the other demos that I showed you, right? But the cool thing is you can build this game very, very quickly doing a whole bunch of things. So what we're doing here is the magic happens. Again, here, let me go back down. I should have done that first, sorry. So what we're doing is we're saying, here's a canvas. So again, nothing's going on in the canvas and the hypertext. All the magic happens within the JavaScript itself. So what we're doing is we're defining variables for bullets and aliens here. And then basically what we're going to do is load the canvas into memory within JavaScript to do whatever we need. Play a sound, which you saw before, or heard, I guess you could say, which was my horrible singing or whatever you want to call it. And then also add event listeners for when the mouse moves, when you actually click the mouse, or if you hit a key, which basically mouse down and key down are firing events and things, right? So basically that's the whole point here, is to actually get your mouse or get that interactivity into the game itself. So these are event listeners that you can see a little bit later. So this is just following the tank. So when your mouse moves, you actually follow the tank around and stuff like that, or the tank follows your mouse, I should say. Firing, so putting a new bullet onto firing and then doing whatever you need to do. And then what we have here is preload resources. So this is, I'm going to show you a slide in a little bit about what a game pattern or a game structure actually looks like. But this is basically where you load all of your assets before you actually are able to play the game. And that's really important, because obviously you can't play the game until you actually load things. So I'm not going to go through all that. This is all just preload asset type of stuff. And then check resources. And then we have something called start drawing. So what we have here is a draw event. And the draw event basically is one of the fundamental components of game design. And I'll explain it a little bit later. So when you draw something, you're drawing the background, you're going to draw the tank, draw the bullets, and draw the aliens. So basically what you're doing is you're creating a picture, for lack of a better term. It's technically not a picture, per se. But as far as, you know, if you were to pause the game, it just looks like a picture on the screen. And basically the draw event draws all that stuff to the screen, to the canvas in this case, and actually puts it there and waits for the next frame to happen, in which case it'll draw it again. Okay? And there's some information, or here's a function to actually draw the background, which gives a whole bunch of assets here. Draw the tank. Again, I'm not going to go through the code because it's basically I explained what it is. Draw the bullets, and then draw the aliens associated. And then also here's the play sound thing. So here I have, you know, an MP3 audio file that I'm using, which was my blah 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 song. And that's basically it. So that's all we have to do with that. So I'm just going to go back to my slides. Any questions around that? No? Okay. All right. So we went through quite a bit of information there, a demo I should say. Hopefully it was clear to you, but there's all sorts of things that are really important for game design, and the good thing is if you want to create games that are web-based or have web technology such as HTML and JavaScript, as you saw, you can absolutely do it. So what you have here is an example of how things sort of look from a document object model. You have your container, which is just the container for the document object model. The canvas sits inside that, although this picture is a little bit off because it's basically saying that a game canvas is smaller than the container, which is actually not the case. The game canvas can be as big as a container. It's just in order for you to actually notice that there is a container in a game canvas, we've sort of put the two smaller than each other. And then you have something like a button, for example. Now let's see what this looks like. So from a document object model standpoint, basically you have the canvas, which you saw before, which is in your container, which is a div, right? So you define that. And then you have a div for the snowball button, which is basically an image or whatever it is that you have. But you notice here that the canvas is different than the snowball button. So you can actually superimpose an image or superimpose something onto the canvas if you wanted to as well, which is possible. So there's lots of ways that you can actually interact and put stuff onto the canvas, or at least, quote unquote, make it look like it's putting stuff on the canvas, when in fact, if you think about that example of the Apple Mini iPad type of thing where it was in a glass case, the button that you saw in that previous slide is actually on the front of the glass. So you could actually technically touch that if you want, whereas everything on the canvas is behind the glass itself. Okay. So the other thing that we need to talk about is resizing, because obviously when you deal with HTML web pages or even with Windows Store games, you're not going to necessarily know exactly what the size of the screen is that you have. And one of the beautiful things about HTML is in the cascading style sheet side of things, CSS, this has been around for a little while now, there's something called what's called a media query. Anybody here heard of media queries? Yeah, a few of you? Okay. Media queries are a beautiful, beautiful thing, and they allow you to do an awful lot. Now, there's this whole idea of something called responsive web design, which I'm not going to talk about in this talk because there's too much to talk about with it. But the bottom line here is, media queries are great to actually show you how you can resize things or get capabilities of the device that you're on and things like that. So what you can see here is that we have something like a viewport. So you're basically saying that the media query is going to get the width of this sort of canvas in this case, if you're using this in your CSS, is saying, I want the game to be the width of the device and the height of the device. Or you can actually do things like, if the screen is available, in this case, in the second one here, and the orientation is portrait, so you can actually, this is where the query part comes, right? So you're saying, if these conditions are met, then the viewport is going to be, say, for example, 768 pixels in width, and then 1366 pixels in height. And then you have basically all your layout stuff within CSS. So this is an example of the DOM example that we had before, where we have the canvas, and then we have the button as well. So here you can actually do some interesting things with the button for handling the position and all that kind of stuff. So the button itself, which was that snowball image or whatever you want to call it, you can actually define where it's going to land on the screen via the CSS as well, which is actually quite good. So I'm, again, not going to go too much into that. What I am going to do is show you some examples around CSS, because I think this is something that's very, very important, especially if you're talking about games. So I'm going to go back to my trusty Visual Studio console here, or Visual Studio app, I should say. I'm going to go to my CSS examples. So the first one I want to show you is border shadow. So one of the cool things around CSS 3, which is the new standard under the HTML5 umbrella, is that a lot of the stuff that was really difficult to do, that required you to do unnatural things again within JavaScript, such as border shadows and all sorts of things like that, we have the ability to do within CSS now with a very, very little work on your part as a developer to make happen. So if you take a look at it, here we go. I'm going to go right down here. So here we have a div with a paragraph, right? Nothing too wild. This is just text. What's up, right? Pure imagination. And all we have here is some CSS. So what I've done is I'm saying that the style for this div, so the div that you see right here, right? We're going to say that the background is going to be this test image.png, right? Test.png image. And then we're going to have some margins, paddings, and then these two things here, border radius and box shadow, which, as you can see highlighted here, are specific to CSS3. So if you're using CSS2, you do not have access to this, but if you have CSS3 capability within your browser, you absolutely do. So this is something that you can actually do some interesting things with, and I'll show you this in a second. The other thing that we have is we have here the paragraph style, which was, as you saw here, the paragraph. We've added, the color, the font size, which is all stuff that's been around for CSS for a while. But again, these two things that you see right here are specific to the new standard for CSS. Opacity, so you can actually have something that's transparent or semi-transparent, translucent, whatever you want to call it. And you also have, you can create backgrounds. So let's take a look at what this actually looks like, I should say. Wait for this to come up. There you go. Nothing too wild there, right? But it is kind of interesting all the same. So what we have here is the background image, which is this checkered thing, just to show that that there is a transparency within the paragraph. So basically, this is your div right here. And if you notice, we have rounded corners, which I actually created on the fly, and we have the border. We have this the border shadow, or I should say the box shadow, which was created in CSS as well, automatically, without having to do anything else. And then inside the P tag, which is a paragraph tag, basically here's Chow, pure imagination. So this isn't an image, this is just a box. And here we have the color and then the transparency associated with it. Nothing too wild. Okay. All right. Media queries. So I talked about media queries already. What I'm going to do is I'm actually going to show this to you first, because I think it's easier to show you. All right, so there's a picture of my hand. High five, right? Okay, so if I do this, whoop, I'm giving away the demo already. There we go. So basically this demo is showing how you can use media queries to respond to the size of the screen and give you a behavior associated with that screen if you need to. So if I take a look at this, I'm going to, whoop, there we go. Go like this, wait for it. As the screen gets smaller, 4. Anybody care to think what's next? 3. Yeah, 2, that's right. And then 1, yay, all done. So this is typically dealt with when you deal with mobile devices, so if you have a smartphone that's actually surfing the web, this type of idea is actually really, really useful because of the fact that it allows you to scale your site appropriately. And what I mean by scale is not make this text smaller and everything else like that, but actually make your user's experience on a mobile device much more pleasant for your website. So you actually physically change the look and feel of your site via media queries so that you can actually allow the user to do whatever they need to do effectively on your site without having to squint or zoom into a specific part of the site and things of that nature. So let's find out what this actual, here, I'll just maximize that first. Let's take a look at this. So again, what I have here is a div. That's all I have in the hypertext itself. Now let's take a look at the div. Where is it here? Okay. So basically the box, which basically I called it right here, it's class box. So the style for the box is basically saying, repeat, all that kind of stuff, the height and the width, and then say the images is 1. So this is default, right? So basically this is if all else fails with the media queries, it's going to show the thumbs up picture that you saw, okay? But if the minimum width of your screen is 450 pixels and the maximum width, so if it's between 450 and 500 pixels, show the 2, which was the peace sign, right? And set the height and the width to equal to that. And then also between 500 and 600 pixels, make it 3, I think it was like that, and then so forth and so forth. So without actually doing any JavaScript or doing anything within the hypertext, strictly using media queries within CSS, you can actually define the behavior of your web page with that. And this is really important for game style as well, because of the fact that you never know what size screen your game is going to be, and this is an effective way to actually manage that. All right, I think this is going to be the last demo that I have. Okay. WAF. Anybody heard what WAF is? No? Okay, Fred, you don't count because you already know what it is. Yeah. Okay, so it stands for, I believe it stands for Web Open Font something or other anyways. But basically what it is one of the problems that web designers and web publishers generally have is they have an issue with creating these great font experiences, typography experiences with their users, because they don't necessarily know if the font that they want to use is installed on the user's PC. The WAF set of standards allow you to actually use a font that's existing on the website itself, and then download the font and install the font for that web page only. So that's kind of a cool thing in of itself, right? So you can actually do some cool things with that, because it means that you can create and use the font that you want to have so that you have that experience for your users, which is really important. So for example, let's take a look at this. I have a header tag with just saying hello WAF, right? And what I have here is, actually I'm going to fix that because that was something that I was doing there. We have font face for this basically thing saying 3 dumb regular, and then basically here's the details, the source, font weight, font style, and then the font face I'm saying here. So basically what I'm doing is I'm saying the font will be 3 dumb regular, Arial as a backup, and if I don't have Arial then sans serif. Pretty simple. Now let's take a look at what this looks like. All right, hello WAF. Now this might look like an image, but it's actually not, because you see I can actually highlight that. So this is not something that would typically be found on a user's PC, this font. In fact, it's quite a horrible font, but at least it brings across the idea of what you can do with fonts as well, right? Now, just to show you what happens if I change this. So if I change this to Web Font 1, which doesn't exist on my PC, I'm going to save it, going to run it again, and it's probably going to be cached. So we'll wait for it in a second here. Oh, no, it wasn't cached. So basically what you see here is this is now an Arial. So we got the backup if need be. So right away, you can find that you have the ability to create these great experiences using fonts as well, which is kind of cool. So that was it for my CSS demos. Game structure, okay. This is really important. So as you can see here, here's an example. We have 4 frames that we're just showing right here, and as you can see over time, so frame 1, then frame 2, then frame 3, and as you can see the little guy here is moving further up the mountain. So a frame is basically, for all intents and purposes, like I said before, a picture. So the game actually draws all the assets to the screen for that frame, and then just waits for the next frame to be ready, in which case it'll draw it again. So that's generally how it works. You basically have this pattern when you're dealing with games, and this is true of pretty much any game out there. This is the general pattern. You have initialize, which is basically load your assets and everything else like that, which you may have seen or remembered seeing in the game that I showed you earlier. And then you have a couple things, update and draw. So literally, that is the pattern that you use for gaming. Set up your assets and load them into memory as required, then update the screen according to the state of the game, right? So something had happened from user input or whatever it is, maybe your AI within your logic for your aliens or whatever. Update the states of the game, and then actually draw the new frame associated with that new state. And you keep doing that forever and forever and forever. Now, if you think about that, that is actually the crux of why, for example, things like Halo and some of these really, really intense games as far as like graphics and things like that are concerned, that's why they require all the massive hardware, is because they got a lot of processing power that's required to actually make things work, because literally what you're doing is you're updating a screen up to 60 times a second, like 60 frames a second, maybe even more depending on what kind of hardware you have. So as a result, in order for the game to make it fluid and to make it all those types of things, you need decent hardware. So that's one of the things that you have to keep in mind. Going to go over this fairly quickly, the types of objects you have in a game, because I kind of explained a little bit, maybe not in the words that you have here, but basically system, which is your global sort of system things that you have, everything from global variables to state of the game and everything of that nature. Then you have things called managers, and what managers are is they allow you to control the logic of the game. So everything from multimedia to maybe sort of AI control and everything else like that. They're basically things that are happening throughout the game that require something to manage that resource. And then finally you have entities, and that's basically the things that you typically see on the screen. So in this case, the snowball, abominable snowman, the Yeti in other words, hikers and things like that. That's basically what you would see. Or aliens or tanks and things. So we already talked about this, the game loop, so I'm not going to really go over that. This is generally how the game loop works in the Yeti bowl that you'll hear about a little bit later in another session. So you have the initialization, and then basically what we're saying is that date now minus last is basically all that kind of thing, and then get a game tick. So basically what you're doing is that every single time that there's an interval change, so in this case we're doing it by time rather than by frame, draw the new, update the state game, the state of the game, and then draw the new frame. And then when the user says, I'm done, or you're dead, or whatever it is that they have, unload all the assets and then clear it so that you're ready for another game, or just unload it so that the user can leave the game and return the resources back to the memory of the PC. So again, this is how it kind of works. Fred's going to go over this a little bit later, so I'm not going to go too much more into that. So again, this is an example of how the date and time works. So basically what you're doing is saying that on the update loop continues to go all the time. So on the update side of things, which is your business logic, just say, is it time for me to update the game state? If not, then I'm going to go through the loop one more time and just ignore everything and then wait until that game state requirement change is necessary, and then I'm going to do everything that I need to do. So that's where you see the update. And then reset the game tick so that you're ready to go. Okay. And again, finally, if the update is required and the state has changed, then draw the new frame and then you're good to go. I'm not really going to get too much into this because, as I said before, Fred's going to get into this a little bit. But basically, the namespace is like the globalization and the localization of your variables. So understanding what is supposed to be global, what's supposed to be local and things like that. So you have to be very, very careful about how you sort of assign your variables, like you would in any sort of program, right? There's a difference between global and local. You don't want everything to be global because then that stuff resides in memory for the entire time of the game. But there might be some state types of variables that are required for that entire game as well. So just be aware of that, and that's basically what this is all about. And then Yeti Bowl, again, this is just sort of setting the stage for Fred's talk, which is coming up next. You can see here are the various different assets. You have an abominable snowman up here, also known as the Yeti. You have the hiker, snowballs, what the Yeti's actually going to send down. You have the mountain, which is sort of the background, and then you have all the various different assets. Nothing too wild there. I think everybody can sort of get that. And basically you have a wrapper, a frame wrapper. So this is basically, every single time that you need to do something with the frame, the actual implementation of the Yeti Bowl game is done within the frame wrapper. So basically what they're doing is that they're saying, in this case, draw things within the frame and everything. So for example, the methods for the draw part of the loop is draw the X position, draw the Y position as you see here, and then getting all the elements that are required from HTML into memory, and then do whatever you need to do to draw various different things. So draw angle flipped, which is happening if you've actually boiled down a hiker, and then scale it as appropriate. So again, just some information to set the stage for Fred's talk. And then state machines. State machines, as we sort of talked about game state already, this is kind of basically what it is. It's like for every single frame that you're drawing or every single time interval that you're drawing for, what is the state of the game? So like how much health does the hiker have, for example, or something like that, or how many snowballs do I have left? All those types of things, state of the game, or like even where is the hiker now, right? How many hikers are on the mountain? All those things are part of the game state, and you have to keep track of that from every single time that you go through the loop. So this is all about making sure that you have all that information and you store it appropriately so that it can be used within the update function. Make sense? Okay. And here's an example of state. Again, I won't go too much into it. It's using a switch statement for case. So again, just loading the various different states that are required there. I'm not going to get too much into that. Interpolation is not something I'm going to get into a whole lot because I know Fred's going to deal with that. He said that he had a few slides on that. So basically what this is just sort of understanding and figuring out exactly or guessing what the next set of moves are and things, right? So doing more than the update requires, but it's basically anticipating things so that, it makes it easier for the next update. It's less resource intensive and things of that nature. So you actually can offload some of the requirements of the actual processor to actually build out the new screen and things like that going down. So that's it. Here's some resources that might be of interest to you. One of the books that I've actually grabbed is actually really, really good. It's HTML5's games creating fun with HTML5 CSS and WebGL. WebGL is not something that we talk about here because that's really only on Google Chrome's browser. But basically the whole idea there is that it goes through the process of building a game, what you should think about, what you should not think about, tips, tricks, all those types of things. Really good. And I do want to plug introducing HTML5 game development because that's one that Jesse Freeman, who is actually one of my colleagues out in the US in New York City, who just joined Microsoft as an evangelist, he wrote that book for O'Reilly. Fantastic book, definitely worthwhile you're checking out. And then you can see here's a few resources on the web that might be of use to you. The HTML5gamedevelopment.org, which is a great resource for references and everything of that nature. And then if you saw in the keynote, Grant Skinner talking about his work with Atari, there is a developer component to that I'm sure you were probably pretty interested in if you were in the keynote. You can get all the things like Create.js and Audio.js, I think it was, and things of that nature. The libraries necessary to create an Atari game. So definitely take a look at that. And developer movement. So the other thing that I do want to talk about is the fact that we have this great program called Developer Movement. And if you've not heard of it, it's worthwhile checking out. So developermovement.ca, basically what it is, build an app for Windows 8, so a Windows Store app, or a Windows Phone app, or a Windows Azure service, publish them, and if you do that and you've submitted these apps as well to developer.movement.ca after you've actually published them in the various different stores and such, or a production instance, you actually can get points, and those points can be used for anything from mugs and USB keys all the way through to Ultrabooks or even a home theater system. So definitely take a look at it. If you're going to build a game or an app already for Windows Store or for Windows Phone, why not just enter this as well? It's just gravy for you, right? So definitely take a look at that. Finally, here's the legalese around the session evaluation. So basically saying that we're not going to take your info, so don't worry about it. Trust us. Trust us. And then also here is the session eval. So did you like what you saw? Did you not like what you saw from me today? Either way, please let me know. This is the URL that you can go to. I would love to hear your feedback. And as I said before, if you're interested in hearing from me, you can contact me right there. Paul LaBerge, @PLaberge is my Twitter handle. My email address is actually paul.laberge@microsoft.com. So if you want to contact me via email instead, feel free. And Root Studio, definitely take a look at it. We're going to be posting an awful lot on game development there over the next little while. So thank you very much for coming. I hope you have a fantastic conference and you enjoy yourselves and enjoy our hospitality. Thank you for coming.